That's fine.
Okay. Just stay seated. I can do this.
I'm sitting all day, so I'm glad that I can walk.
Same for me.
I think that's all. So we can do this again.
I hope this to be a more interactive session and
Yeah, sure.
this interaction don't goes too good.
Yeah, sure. My last information was that the followers have recorded it.
Yeah.
We can edit it anytime. Yeah, but don't worry about it. Just
I don't think everyone for example.
yeah, sure. The mic is there.
Okay.
But don't worry. Just do plan.
Thank you very much. Hello, I'm glad to be here and thank you very much for coming. My name is Matthias Runge. I'm some kind of old school boy and being packager for a quite long time. And I'm working for Red Hat, but this is not the reason why I'm here. I would like to tell you something about packaging, or would like to get you to become a packager. So before we start this, I want to know something about you. So who's already a packager? No, you. One. This is good. Thank you. But you the rest of you don't have any packaging experience, or do you have packaging experience for Debian or whatever? Okay, so and most probably you don't even have had a look at our packaging guidelines or whatever. Anybody has? Long time ago. So I thought about this, or I expected that. So I think it makes sense to give a short overview of our packaging guidelines, and I'd love to come to a second part where most probably you should put your first spec together and we should have a look at that and review them all together, because reviewing will get you the most experience, and you will learn the most or get the most of it when just looking at others' packages. The same is true for code and so on. So I already said that we will do a short overview over RPM and what's cool on RPM and why we should use it and why it's not Docker. Well, that was easy. And I will tell you a bit about the process of building packages, and the final part will be how to get a package into Fedora and EPEL. So first about RPM. Software, oh, this is still German, I'm sorry. Software packages, it's general, totally disconnected from RPM or DPKG or whatever. It's a piece of software, often it's a piece of compiled code, but in most cases it also contains metadata, like a description, what does this do? If you are just downloading a zip file from somewhere and planning it, you don't get a description, what does it do, and you don't necessarily know what license is this, or you don't have a list of files, for example. And if you ever try to uninstall something under Windows, you know why it's good to have a file list to be able to delete everything afterwards. And also, if you're just downloading a zip file from somewhere, you cannot handle dependencies, which means you're trying to install an application, and this application depends on something else, you are broken until you also include that other software, piece of software, or pieces of software. This can lead to a whole tree of dependencies. And this is something noted in the package description. And in our case, RPM takes care of all that stuff. And if you're using a package manager like yum, DNF, or whatever, this will go out, reach out to the package repositories and fetch all those dependencies for you. So you don't need to care about that. So, looking more deeply into RPM. RPMs are CPIO archives, a really old archive standard, and a little bit of metadata, as I already said. And they are hooked some scripts into that metadata, so you can execute scripts when you install the software. For example, if you are installing a daemon, you could run the daemon, or if you are installing some other software, you could also add a user for that software and so on. And for the removal part, you could stop earlier before removing that software, and you could stop the daemon before removing that software and so on, or even remove the user or whatever. And you could hook a migration script or an upgrade script into the package just to being able to handle upgrades from one minor version to another. Good thing is packages are signed in an RPM case, so you could verify the software I already downloaded is intact and it's not modified during transfer and so on. And this recently hit the Debian or Ubuntu folks a bit because they had two bugs in their updater. First one was updates were not checked if they are intact or not, and the other one was you could insert a man-in-the-middle attack in the update chain, so you could basically install anything on user systems. So to make a distinction between RPM and Debian, for example, package installs in RPM world are intended to be unattended. No user interaction is desired at that point. If you're looking at Debian or Ubuntu packages, if you do an update, you could hook into an update script and say, well, this configuration file changed, do you want me to apply that, or do you want me to merge both files and so on? And this is completely undesired in our case. Just to know. Technically, it's not a problem to hook an update or upgrade script, but it's not wanted. So we have a huge tool set. For example, if you wonder, I have that scary file on my system and I don't know where this came from. You could query RPM, like in the first point, where does this file come from? And RPM will return, oh, because we know all files on the disk and know where they come because of the metadata. This will return, oh, this comes from OpenStack Nova. And you could also, because of the metadata, search all this database to get to know something about the software, or if you're looking for software, there are already tools there. They are just examples. Search for a package or install a package, or even if you wonder if I'm changing this or that file, will I hurt somebody else? Like, which this is the repo query thing. Which software depends on that package or that file or so on? It's something you could, or if you're starting with packaging, you mostly add a leaf package to the package database. But at some point, some other person will add a dependency on your package, and you're becoming more in the middle point or in the center. So if you break something, you not just only break your package, but also all dependent packages on that, because you cannot install them anymore. So you must be aware of, I will disrupt anything behind me. I'll skip the rest. So, to get you started, you need a Fedora or RHEL clone, something like that, and you need to install just 2 packager groups or package groups and a tool. Development tools with the @ sign. It's just good to have them, and Fedora Packager will install nearly the rest of the tool chain. And I would urge you to install rpmlint as well. And for packaging, don't even think to work as root. Not a good idea. I saw so many people, and it's easy to make some silly mistakes and you will just scrap your root file system. So don't. It's not necessary. If you're installing Fedora Packager or the Fedora Packager group, you need to, there comes a quite handy tool named mock. It will build your package inside build root. And to be able to write to that file or directory, you need to add your user to the mock group. It's somewhere hidden in the mock man page, so just to name it. Add your user to the mock group and re-log in, and you are done. It's quite handy. You don't need to write that down. I have a slide containing this later on. So, to look at package descriptions, this is how it looks like. If you're just going to a file specification or a package specification, you have those tags like the package is named, in this case Python Flake 8, and it's not architecture dependent, so we could use the same package on Intel 64 bits and 32 bits and on ARM and whatever. You get a version and release flag. Version means the version of the package itself, and the release is something we add to that point. So if you're just packaging the first one, it would most probably be .1, and if you discovered a packaging issue or whatever, you would increase the release by 1 and rebuild. You see also it's installed from a repo, and you see a summary, you see the upstream URL and the license and so on. So this is just something you get by searching DNF or YAM, which is basically the same. Should be basically the same. So in the spec file, we have a header, as I already said. We have sources and patches named. We will come to that in the second part. and the description we already saw here in the description part. Package build runs in, I'd say, 2 or 3 phases. First, you have first you will take your tarball, most probably your tarball, and decompress your tarball somewhere on the file system. And second part would be a compile step, whatever. Could be a make or some transformation process also. And the third part will be I'm installing my files from the package to the part in the file system. And RPM uses for this specific reason a build root, so it creates the file system, how it would look like in the future if you are installing your package. So for example, those Python packages, they will end up in user lib python 2.7 side packages or whatever. So in your build root case, you will create a build root somewhere. It's done automatically by the tools, and inside that build root, a user will be created, a libdict will be created, and so on until that side packages whatever path. And everything what's inside the build root will be copied to the CPIO archive and will be installed by CPIO later when installing the package. So I already said this. This is most probably the preparation section for the or the first step in build process. Just uncompressing your tarball and everything you basically need to prepare your build environment. The next was the build step, something like Python setup build or autoconf make and so on. And the third one is do your install to your build root. So, final part in your spec file is something like a list of files and a change log. And the list of files we already used that and asking RPM where did that file come from. So you're basically specifying my package will install this and that file at that location, and you also have the ability to specify this file I'm going to install will be a config file. In standard case, if you're installing a file, RPM will just overwrite everything what was before there. But if you're using config files, that's most probably not desired, because you will lose every modification you ever made in your files. And if you're doing an update, you might have seen some config files ending with .rpm new or .apm old or whatever. And this is exactly the reason they are created, or they are tagged as being a config file. Wrong, this one. So RPM comes with a huge set of macros. We already saw those in this spec file earlier. It's just a shortcut for some variables being expanded, but you could also hook functions in there. There's a huge list in Fedora wiki where those are defined, and it's just convenient to use them. So I would suggest you to look that up when you need it. you don't need to memorize them right now. Or maybe yes. So, to get started, you would be to get started. I'm skipping that right now. If you put together your spec file, it's like as I said, the build description and everything you need for your build. Then you would issue rpm build. It's a command you already installed, most probably -ba, and as optional argument is the spec file. And this will run your build, and hopefully it succeeds. And well, that's it. Congratulations, you already built your first RPM. The way we are doing this in Fedora, there are lots of dedicated build hosts. This differs from what Debian is doing. So we are checking everything, especially the spec file, into a Git, and the builders go out and check out the spec file and tarballs from Git and are building that. So the builders don't have even internet connection.
Because even the tarballs are stored in Git, not only patches?
The tarballs are actually stored in a side cache, but it really doesn't matter where they are stored. It doesn't need to interest you. It's just the builders go out and fetch everything they need to build your package. If you're building for Debian, you will download everything to your home PC, build it there, and upload that build part to their infrastructure and distribute it. That bears some risk. Do you really trust whoever built this, and are you sure nothing else is included in that file, and so on? So this is the reason why we are using those build hosts. And they are, for each build, they are installed. So if you're going to build a package, first part, this is something you most probably won't see at all, is they go ahead and install a system for the install the environment. If you're building for Fedora 21, they will install a Fedora 21 host, pull everything you need to build that package, and then the package will be built. Final packages will be copied outside to somewhere else, and the machine will be scratched. So in this part, the RPMs are being published from the build host to a repository, and a small script is running over the repository to create some useful metadata for your packages. And finally, they are pushed to the outside world, or to the internet. So there is a way for you to interact directly with our build systems if you're already in the packager group. If not, congratulations. There's a way to build something like unofficial builds. If you're building from directly from a Git or from the official Git repository, every build is being tagged, and you cannot, or it's not that easy to delete them, and you cannot go back or easily go back in if you found out, oh, well, I had previously version 4 of my system or of my cool application, and version 5 breaks everything, so I need to go back to version 4. This is kind of hard. So I would suggest to try those disruptive changes earlier and you could tell the build system, well, please do a build of my package, and you even get a URL where to download your package, but this is not going to be stored permanent. It's going to be scratched in 14 days, 4 weeks or whatever. And you could also say, I want this built for Fedora 21 or Fedora EPEL 6 or whatever. And this Koji Scratch build also takes source RPM files, which contains tarballs of your code and the spec file itself. It's packaged together to a source RPM. But if you're doing more official builds, just do it in Git and do it with Koji directly. So the hardest part for new contributors coming up to Fedora is how to get the first package into Fedora, because all that strange stuff like spec file, Koji, Bodhi, and whatever. So it's many names you never heard about it, and it's good to win a bullshit bingo also. And if you're new, you are not known to the community, and the package you are trying to get into Fedora needs to go through a review. So you need to convince someone to review your software or your software package. And this is, for the first time, it's quite hard, I'd say. So the steps are the following. You're creating your spec file and your source RPM. You upload it somewhere to the net. You file a request for review in bugzilla. And if it's not your first package, you also need a sponsor, a person being able to tutor you and to promote you to a special group in our Fedora account system. Usually, if you're putting up a new RPM for a review, you just wait for somebody to pick up your review. Of course, you could send a mail to the mailing list, Fedora Devil mailing list, requesting a review. Most probably you will get the answer, well, do reviews yourself, and we could swap reviews. You're reviewing my package and I'm reviewing your package. So if the package was reviewed and everything is all right, you get a special tag in bugzilla saying, okay, this package is okay to go. Then you fill in the next request to get a repository in Git created to hold your package. And finally, you could import your package into the SCM and build it and submit it to the world, and congratulations, first package. A reviewer has to check this package complies to packaging guidelines. The license is okay. For example, it must be MIT license or a GPL. There are quite a lot licenses out there being considered as free licenses, but they contain minor changes here and there, and this makes some software unsuitable to be included in Fedora. For example, there's a license stating this software may be used for good, not evil. And try to get a lawyer define what is good and what is evil. This is not possible. Well, but still, this silly or this small sentence makes the software, even if it's all open source, it makes it just unsuitable for Fedora because it restricts the usage of that software. So the license must be okay. The spec file must be readable. You don't need to win an obfuscated code contest at all. You shouldn't do that. The software must actually build. It's not that common. Software packages proposed to be included in Fedora, but they don't even build on our build system. The reviewer needs to check the files, if the name is okay, dependencies are listed, and so on and so on. And a serious problem becomes we have that rule not to bundle any foreign library into packages. And just copying some library from somewhere, even if it's free software, to your own project seems to be a common pattern. But you all have heard of those OpenSSL issues. Many projects were hit quite hard because so many packages were bundling OpenSSL libraries in older versions or whatever in some other packages. And in Fedora case, for example, we just shipped a new version of OpenSSL and the whole release was safe. Others were supposed to update every package where you could find an OpenSSL code, and this becomes more and more painful. So we need to take care of this. Doesn't happen. We don't need. We are not allowed to bundle stuff. Period. Of course, there might be a good reason for to break this rule, but you need to reach out for a committee to ask for permission to do so. In general, don't even think about that. So the reviewer needs to state common rules are okay, and for example, that Python Flake 8 example, the Python review guidelines are fine as well. There are tools out there to check if your package is okay. First one I mentioned was rpmlint. It just runs through your package, spec file, binary package, and source RPM, and checks if you didn't do any common mistakes. And there's a second program, Fedora Review. This will go out to bugzilla and read your review request and pulls everything down, and will also compile that stuff locally on your machine. Will check for common mistakes, will check for licenses and so on, and outputs you an endless list of descriptions you need to inspect, but still it's a good helper tool. You probably won't miss anything, but still it's not a guarantee, so it's still up to you. Reviewing software is hard, to be honest, and we have tools to support that, but it's cannot be done automatically. So, if you are submitting your first package, you need to become sponsored by someone, as I stated earlier. So you need to convince somebody, and it's more likely to become sponsored in doing reviews in bugzilla. You will learn a lot. It's definitely a time-consuming process, but I think it's worth the effort. And you could also submit more packages for review. But still, it's an exercise to put something together. So in any case, you will learn something. And once you're in Fedora's packager group, meaning you could build your package, you can and should review others' packages as well. So we talked briefly about RPM, package descriptions, and the build and review process. Any questions so far? Anyone sleeping? Great. Problem solved. I have a few references here. They are basically too much to consume at one piece, just to be honest. And especially the last item here, the how to create an RPM package or the packages guidelines, they are a huge amount of information, but they are quite good, and it's worth reading them, at least to skip briefly through. So, now that everyone is sleeping, I'd like you to build your own package. It's not that hard. I heard a clicking behind me, or just seeing you installing development tools, Fedora Packager, and so on. So I'd urge you to do that, and to also to modify the mock config or the groups files to add your user to the mock group to be able to run a mock build, which will build in a build root environment. And just putting a spec file together from scratch is quite hard. You could use an old package to get ideas, what to do or how to do. And the best thing is we also have some tools how to put a spec file together. So in preparation, I just made a small package yesterday. It's named Python Bleach, and it's the other screen. Just to just to create.
Maybe if you can increase font size a little bit.
Yeah, I just thought about changing the color from blue to something else. Would be. Wasn't there an option to use the light theme? I'm blind. Okay. So, if you're doing RPM dev minus setup tree, RPM dev will set up a few files in your home directory named RPM build, and inside there will be several directories created, like RPM build root. I talked about that earlier. RPMs, sources, specs, and sRPMs. So. And as the name suggests, specs is the place to put your spec files to. Sources is where source files go, tarballs in that case. RPMs, you will find the final RPMs there. And sRPMs is what you require or what you use for the package review process or for building RPMs directly on your local machine. Build and build root is not interesting in this case currently. So yesterday I just did this or put this small Python package together. It's the second bullet or the last bullet in this page. I just used a tool named pipe to RPM, which goes out to PYPI and fetches everything located there, like a package description and so on, and fills in that into your spec file. Pip to RPM is an additional package in Fedora. So if you're going to package Python files, it's just neat. So I used something like pip to RPM minus n to give them the PYPI name. In this case, it was bleach, and if you're just using this, it will spit out your spec file directly on your command line. So I just redirected this to my specs file, and pip to RPM will also download your tarball and put it to sources and so on. So if you're just using that, you will end up with a file looking quite convincing. I did some minor changes in the spec file. For example, the script couldn't distinguish which Apache software license this was. So I had to add version 2. This was one change, and I think I had a different change to make, but still, this was a quite easy, quite convenient way to put up a first package. And it handles Python review guidelines or Python guidelines quite well. It puts everything together you required, and basically that's it for the first package. Oh, I forgot. If in the changelog, you most probably should add a name of the packager and an email address. So, and I would take RPM build to go through that spec file, -BA, build everything, or build all, specs, Python bleach, and this will run out, and even if you looked at that, there's a check section running also unit tests for that specific package as well. And this is quite neat. I would suggest, even if you are not intending to build any Python package, just try it out and try to make RPM build your package. If you manage to do that, it's a huge first step. The next step would be to run, you saw that there was a source RPM build over there, and I suggest you to run mock --rebuild on that source RPM as well. It will install everything required to build that package in a change root environment, and if you forgot something, it won't build. So it's a good test for something to be run later on the build host. And there's no reason to swamp the build hosts with defunct processes, because it's a shared and precious resource. And oh, I forgot, we could also use RPM lint, which is a bit opaque if you're just using it from the command line and have no idea what's trying to tell you. In this case, it just says, well, I've checked the spec file and I saw no errors, which is good, but it might be a false positive. So you simply need another person to look at that package as well. And that's all from my side. Questions, suggestions?
Are you aware of any effort how to improve how this bit works? Because now we have tarbos and messing with patches and files.
There are some